Question 3 commences by examining your knowledge of consumer price indices, and in particular the construction of the consumer price index for country A. Now, we're told that in 2015, then this is the year that we need to use as the base year, i.e. equaling an index value of 100. And we're also told information that these 5 goods represent the typical basket of goods. They're what forms the index. We've got the prices, 2015, 2016. We've also got the weightings which we need to use in the construction of the index, because we know that price indices are weighted indexes. So to begin, then before we calculate anything into index form, then we obviously need to know the raw values. So for 2015, we're going to work out the raw values, and to do that, very, very simple. It's going to be the price times the weighting added together for each of the products. So we take our 5.6 times by 25, 3.45 times by 18, 1.2 times by 40, 8.4 times by 5, and 2.55 times by 12, giving us a value of 322.70. And in 2016, we do exactly the same. So price 6.3 times by weight 25, and exactly the same for the other products. And then the value there comes to 336.70. Now we need to convert this into index form, and remembering that 215 is the base year, so 215 is going to equal 100. What's the easiest way of converting the 322.7 into 100? Well, it's to divide by itself and then times by 100. So 322.70. If we divide by 322.70, we obviously get 1, times 100 will give us 100. So there's our base year. And the rule when we're generating and constructing an index is that whatever we do to the data in the base year to convert to 100, we have to do to the data in any other year. And this keeps it in proportion, the index in proportion to the raw figures. So this time we take our 336.7 and we do exactly the same as we did to the value in the base year. So we divide it by 322.7 and times by 100. And this gives us a value of 104.34. And that was the answer to 3A. And we can work out easily from that the percentage increase in prices as measured by CPI in country A was 4.34% in that year. We are next given some inflation data for country B. And the first part of this question asks us to consider 1 year in which the country experienced deflation and 1 year in which it experienced disinflation. Now we can see from the data that between 2008 and 2009 the price index fell. Okay, so prices in this country B reduced in that year, so that obviously indicates deflation. Now between 2011 and 2012 the increase in prices was not as great as in the previous year. The index rises from 100 to 110, going from 2010 to 2011. Then from 2011 to 2012, it increases by 5 index points. So the rate of increase in prices is slowed, and therefore we can say that that country has experienced disinflation between 2011 and 2012. And don't forget with that question, the clause in the first sentence, first part of the sentence, using the data in Table 2 to support your answer. So you must state the data as well as the fact that deflation occurred 2008 to 9 and disinflation occurred 2011 to 2012. The second part here asks us to calculate the change in real GDP per capita from 2010 to 2012. Now we're given the nominal GDP per capita, and we're asked to use the inflation data in Table 2 as the deflator to convert nominal to real values. So that's where we're going to start. So we know that GDP in 2010 was equal to $800 per month, and for 2012 it was equal to $940 per month in current prices, so i.e. in prices from the year 2012. Now, to reduce that by the rate of inflation will give us a figure for real GDP measured in the base year prices, i.e. those from 2010. So if we look at the table, we can see that prices have increased from a base of 100 to an index value of 115. So we know that prices have gone up over that time by 15%. Now, if we were working out a percentage increase from 2010 to 2012, we would take the price level in that year and times it by 1.15 to indicate that 15% increase. So if we want to go back in the other direction to deflate our price, our value in any sense, our nominal value, then we just need to do the reverse. So we need to divide by 1.15. Okay, so we can do that to our figure for real GDP per capita of 940, divide it by 1.15, and that gives us a value of $817.39 per capita, and we have therefore converted that value, that nominal value, into a real value. Notice that we are dividing by 1.15 rather than timesing by 0.85 because we're not trying to reduce the 940 by 15% of its value, but we're trying to find 15% of the original value before inflation had taken hold. So we've now converted these into comparable figures, i.e. into real data. So we just use our standard percentage change formula that we've talked about a number of times before. Difference divided by original times 100. Okay, so the difference is our 817.39 minus 800 divided by original value of 800 times 100 to convert it into a percent. It's 2.17%. The next part of the question looks at the imposition of an indirect tax in country C. We're given a supply curve for the market supply of sugar once the tax is imposed, and it's given to us here, and we're asked then to plot and label the supply curve. So the easiest way of doing this is to take some points for some values of Q, put them into the formula, and then solve for the corresponding price coordinate. So taking a point to begin with where quantity supplied is equal to 0, so we can say that 0 equals minus 400 plus 5p, so 450 equals 5p, and p equals 90. We can now plot this value, so when Q equals 0, P equals 90 onto our diagram. Then we'll just take another point, so for example we'll say when QS, quantity supplied, equals 150, then 150 equals minus 450 plus 5p, so 600 equals 5p, p equals 120, and we can then plot that onto our axes as well. That's that. And our final point, when quantity supplied equals 300, so 300 equals minus 450 plus 5p, 750 equals 5p, p equals 150, and then we just pop this also onto our diagram, and we can see there that those points are in a straight line, and with a ruler, which I shall singularly fail to do now, we can mark on our new supply curve and label it S with tax. The question now moves on to ask us to make some further calculations around the imposition of this sugar tax. And firstly, we're asked to state the size of the sugar tax per tonne. Now, we know that the golden rule around finding indirect tax sizes on distances on the graph is to go to the new equilibrium, which is here, and go vertically backwards to the old supply curve, this distance here, because the vertical distance between the supply curves gives us the value of the tax per unit, that distance there. If we just read off that, we can see that its value is 80. Okay, so the difference between 120 and 80 gives us that vertical distance. Okay, so the value of the sugar tax per tonne is 120 minus $80, so that is $40 per tonne. Skipping ahead to part 4, we're asked to determine the incidence of tax per tonne on producers of sugar in country C. Now, the fact that we are asked per tonne is very important. So we're not trying to calculate the total area of incidence on the producers, but only the amount per tonne. So we should know that our total tax revenue box will be this area here. Okay, so that area there. And the incidence that the producers bear will be the area of that tax revenue underneath the old equilibrium price. Okay, the old equilibrium price was $90 per tonne, and now, after the imposition of the tax, the firms actually only get to keep $80 per tonne. They've increased price by $30 per tonne, but they're giving $40 to the government, so they're only keeping $80. So the total producer incidence would be the area there, but we're asked per tonne, so we don't need to times it by the quantity, we're just looking for this vertical distance between 90 and 80. So our answer there is our $90 minus our $80. So the incidence on the producers per tonne is $10. Now coming back to part 3, calculate the producer surplus which will be earned following the imposition of the tax. Well, the new equilibrium after this imposition of the tax, there's a supply curve, there's our demand curve, is here. And we know that the producer surplus is the area above the supply curve but below the market price. Okay, so it's that triangle there. We can just shade that in and label. So there is our new producer surplus. You can see what that means. So we are asked to find the area of that triangle there. So a little bit of simple mathematics. The area of a triangle is half base times height, and we can see that we have half times the base, which is that length there, which is the same as this, 150,000 times by the height, this distance there, which is 30 . And this then gives us a total value for that producer surplus of $2,250,000. A few people struggled with this, and where people had attempted it and got into the right kind of areas, you'd forgotten the fact that quantity is measured in thousands of tons, and just used 150, not 150,000. So your answer is out by quite some magnitude.